All right, today we are getting started with domain and range. We are going to consolidate this a little bit. We used to break this up into a couple different days, but today we are going to talk about interval notation, inequality notation, and what is referred to as set builder notation. So first, what is domain? Domain is all accepted inputs or our x values. Now, when we're talking about a function, we can have certain domain restrictions, as in x values that are not allowed. And there are two things that determine this. One is that we cannot divide by 0. So if a certain x value would cause you to divide by 0, it has to be excluded or left out of your domain. Secondly, we cannot take the square root of a negative number. So if there is an x value that would cause you to take the square root of a negative value, it also cannot be in your domain. So if you have a function with no variable in the denominator and no variable in a radical, then there are no domain restrictions, and our domain would be all real numbers, aka negative infinity to positive infinity. So quickly, we are going to be doing problems with interval notation and inequality notation. So some info on interval notation. We have parentheses and brackets. That is what makes it interval notation. If we have parentheses, that would include like an open circle, the value is not included in the set, and we always use it with infinity, whether it's positive or negative. Brackets indicates a closed circle or the value is included in the set. Inequality notation, you've got your less than or greater than. That would kind of correspond to a value that would be with a parentheses. Again, less than or equal to, greater than or equal to, that would be a closed circle or a bracket. Or if there is simply one value that's excluded, I can just say x does not equal that number. And then I would know that every other number is valid. So let's practice. First, we are going to determine what domain restriction we have, if any. This first one, 2x minus 5. I don't have x in the denominator, and I don't even have a square root. So I have no domain restrictions. So our domain is going to be negative infinity to positive infinity, and I use parentheses for both of those because they're both infinity, or you can just say all real numbers. That symbol indicates all real numbers. Either of those is acceptable. On to number 2, t squared plus 3t. Again, I don't have a denominator and I don't have a radical, so that is going to be none. And so you've got the same domain of all real numbers. On number 3, okay, I have x minus 5 in my denominator, so this is restriction type number 1. I cannot divide by 0. So I have to think, what x value would cause me to divide by 0? Now, if I plugged in 5 for x, that would give me 5 minus 5, which would mean I have 0 in the denominator. So x cannot be 5. So my domain has to be all numbers except 5. So I can have numbers smaller than 5, so like negative infinity to 5. Now the infinity gets a parentheses because it's infinity, and 5 gets parentheses because I'm leaving it out. But then I can also have numbers that are greater than 5, so I could have 5 to positive infinity. Again, infinity always gets parentheses, and again 5 gets parentheses because I'm leaving it out. Now because I have two intervals, I have to put the union symbol, capital U, between them to indicate it's both parts. So that is my interval notation. My inequality notation, I could just simply say x can't be 5. Okay? You will end up developing a preference for which one you prefer, but sometimes you will be specifically asked to use one or the other, so you need to be comfortable with both. Okay, on number 4, I've got a square root of x minus 7, so that is restriction type number 2. I cannot take the square root of a negative number, so I have to figure out what values would make this become negative. Now it can be 0, I can take the square root of 0, but it cannot be negative. Now any number smaller than 7 is going to cause it to go negative. So I'm going to have all values from 7 to infinity. Again, infinity gets parentheses always, but the 7 is going to get a bracket because it is included. I can plug in 7 here and have an output. So that's my interval notation. My inequality notation would look like x is greater than or equal to 7. Okay, on number 5, again, I have restriction number 2, I cannot divide by 0. That value that would cause me to divide by 0 is -3, so my intervals is going to be all numbers less than -3, but not including it, and all numbers greater than -3. For my inequality notation, all I would say is that t cannot equal -3. And I guess we could correct that to say t instead of x. And here as well. Okay, on the next one, I cannot take the square root of a negative, and this one is not quite as clear as 4 as what the domain restriction is going to be. So what you can do is solve this like an inequality. So if I'm going to take what's inside my square root, I've got 5 minus 2x. I want that to stay greater than or equal to 0. I can just solve this inequality for x. I can subtract the 5 and then divide by -2, which means the sign of my inequality changes. So x has to be less than or equal to 5 over 2. There is my inequality notation, but then for interval notation, this means all values less than or equal to 5 over 2. So that's going to be -infinity to 5 over 2. Infinity always gets parentheses, and here 5 over 2 gets a bracket. Okay, on 7, I have no restriction, so my domain again is going to be all real numbers. And on 8, I've got both. I have a square root in my denominator, so this is not going to change too much. I'm going to follow my same rule for radical, except that it cannot be 0. So x minus 7, instead of being greater than or equal to 0, it has to be greater than 0 because I can't divide by 0. And this one's just a one-stepper to figure out. So x has to be greater than 7. That's going to be my inequality notation. For interval notation, that's going to be all values from 7 to infinity, with both getting parentheses. Another thing I think I forgot to mention about interval notation is that we always write it in order from least to greatest value. Now we are going to practice stating domain and range from a graph. So we are going to do this in both interval and inequality notation. So looking here, domain is just my x values, so that goes all the way from -9 to +10. For my interval notation, again, I've got the open circle here, so that's going to imply a parentheses. And then I've got a bracket here because of a closed circle. So there's my interval notation. For inequality notation, this is going to look like a compound inequality, -9, x, +10. This one does not get an underline, again, because of that open circle, but this one does. And again, we're going from smallest to greatest values. On B, this one's going from -10 to +10. Again, I'm just looking at my x values. Open circle means parentheses, closed circle means bracket. And then from -10 to x to +10, this one gets an underline, again, because of that closed circle. And then lastly, we're starting at 0 and going off to +infinity. So for my interval notation, that's going to look like bracket 0 to infinity with parentheses. And for inequality, that's just going to be that x is greater than or equal to 0. Okay, moving on, we are going to look at range. We are going to practice stating range from a graph in our inequality and interval notation. I mean, range is your y values. So looking at all three of these graphs, these arrows are not explicit, so we're going to add them in. They got cut off. We want these going off forever. So on the first graph, my range, my y values, I'm bouncing back and forth from -3 to +3. And I don't have any gaps, I don't have any open circles, so we're going to include those values. For my interval notation, that's going to look like -3 to +3, both with brackets. And for my inequality notation, -3 is less than or equal to y goes in the middle now because I'm talking about range, not domain. And they both get underlined again because I don't have any open circles or gaps. Number 2, my y values start at -6 and are going off to +infinity. So in inequality notation, that's going to be bracket -6 to +infinity. And in my inequality notation, y is greater than or equal to -6. Okay, on 3, my range, again, these arrows are going off in both directions, so my range is all real numbers, or negative infinity to positive infinity, which we can represent both ways. Okay, this next piece, draw a graph given the domain and range. Now, there's multiple different ways to do this. On this first one, I've got brackets for everything, so that's going to indicate closed circles. So what I would recommend doing in a case like this is making 2 ordered pairs based on your domain and range boundaries. So starting with domain, that means I'm going to have to go from -3 to +8. And for my range, I'm going to have to go from -6 to +10. Now, because everything is closed with your brackets, I can just simply draw 2 closed circles at the boundaries and draw a line connecting them. You could also switch the points to go like uphill instead of downhill. Up to you. There's multiple different ways your graph could kind of look parabolic. It doesn't have to be linear. Again, up to you. Now this next one is a little bit trickier. Again, my domain boundary is -2 to +11, and my range is -4 to +2. Now the domain restrictions both have parentheses, which would indicate an open circle. And I just have to make sure I get all of my y values. Again, multiple possibilities here. You just have to make sure that all values are accounted for. Okay, last thing we are going to talk about is another representation for domain or range, and that is called set builder notation. So if you don't have a continuous graph, you just have ordered pairs, those graphs still have a domain and range, but you can't write them as intervals or inequalities because there are numbers in between them. When I'm saying all values from 1 to 2, that includes all of the decimal values in between, like 1.5, 1.25. But when you're looking at items like this that are just specific points, you don't have those values in between. So we use what's called set builder notation, and you literally just list out your x and y coordinates. So for domain, I've got 10, 1, -6, +6, and -2. So my domain, you're going to do squiggly bracket, 10, comma, 1, comma, -6, comma, +6, comma, -2. Close squiggle bracket. Same for range, and you do your y coordinates, -9, comma 1, comma 8, comma -4, and -4 is on there twice, but we don't have to write it twice, okay? So here's all my domain values, here's all of my range values. For this next one on the graph, same thing, squiggle bracket, I've got x coordinates, -2, -1, 0, 1, and 2. For my range, my y values are 11, 8, 5, 2, and -1. So that is called set builder notation. You got a little bit of information here on the way that it's read, but again, you can't use interval or inequality notation when all you're given are points or a graph with points, because you don't have all of those tiny infant values that are in between. Okay. And this wraps up our domain and range notes for the year.